the complex numbers of algebra. We want to be able to take the square root of a negative number, something like this. However, we cannot find a number such that when we square it, will give us a negative number. So at the moment, we say that this has no square root until now, until mathematicians created the complex number system. And the complex number system allows us to find the square root of something like this, all right? So what we have to do here is we have to create a new number. We call this number I. I stands for imaginary. So what we do is we define this number I. I equals to the square root of -1. And if we square I, then we get -1. So I is an imaginary number, but when you square it, you get a real number. And by defining it like this, we can now find the square root of a negative number. So that's, in a nutshell, what complex number is. So let's first write any of these radical with a negative under it in terms of I. So what we do is we go, we can write that as 5 times -1 because that's what -5 is. And then we can use the product rule to split it up like that. And then we know that this is I. So then you bring I to the front, and then this is equal to I rad 5. So write in terms of I. We did right here. Write this in terms of I. So the trick is to write this number as a product of itself times -1. And then use the product rule to split it up into that. And then according to the definition of what this equals to, it equals to I. So therefore we get I rad 25. And we know that 25 is a perfect square, so it becomes 5. And then we have 5I. The square root of -50, so same thing, the trick is to write it as 50 times -1 and then proceed to split it up, and this becomes I, and then this is I50, and then we know that 50 is 20 times 2, that's 50. 20 is a perfect square, so therefore, 25 is a perfect square, so you can take out 5, and then you have 2 left inside, okay? So that's how we write any negative roots, any negative radical in terms of I, which is now imaginary because it doesn't really exist. Okay, so for any positive real number B, sorry about that, ignore that for now. We can also, the next thing we want to do is we're going to try to apply operations to imaginary number, operations that we use for real numbers such as addition, subtraction, multiplication, division, and so on and so forth. So what can we do? You can add imaginary numbers. And the way how you add imaginary numbers is you want to make sure that the numbers under the radicands, the number under the radicals are the same. It contains the same imaginary, they're both imaginary. And then what you do is you add their coefficients. So the coefficient for the first term is 1. Coefficient for the second term is 3. So when you add them together, you get 4. So you go 4I root 2. So you keep those. Okay. You can also multiply imaginary numbers. There's a lot of ways to multiply imaginary numbers. But one of the ways you do them is when you see the square root of -4I, what you want to do, the square root of -4, you want to take out an I, so that turns into a positive number. You can also take out an I here, so that turns into a positive number. And then we know that this is 2. We know that this is 5. Finally, you put the numbers next to each other, so I put 2 times 5, and then I put I times I, and because there's 2 i's, and we know that 5 times 5 is 10, I times I is I squared, So therefore that becomes, this becomes 10 times -1 because I squared is -1, and therefore that comes out to be -10. Okay. Rationalize the denominator. So similar to the fact that you can't have radicals in the denominator, you're not allowed to have imaginary numbers in the denominator. So when you see them, you must get rid of them. So the way how we get rid of I in the denominator is we multiply the top and the bottom by I. So multiply that by I, that by I. So therefore you get 2I over 3I squared. Now, from now on, every time you see I squared, replace that with -1 because that's what I squared is, see? So therefore, when you simplify this, you have 2I over 3. There's no longer any I in the denominator, so you're done. Okay, all right, so rationalize this denominator. So similar to what we did earlier, the first thing we're going to do is we're going to write it like this. Okay, write it like that. And then we want to get rid of the I and the radical 2. So to get I to go away, we need to multiply it by I. To get the radical 2 to go away, we need this to be a 4. So therefore, we need to multiply this by rad 2, so it also becomes a 4. So do that to the bottom and the top. So when you multiply this across right here, you get 6I rad 2. When you multiply the bottom across, you get I squared, and then you have rad 4. So you have 6I rad 2 over 2 times -1 because I squared is -1. So then this cancels out, and therefore you have -3I rad 2. So not only did we remove the denominator, but we also removed the I. Okay, awesome. All right, so this is the major portion of what you're supposed to know for this section, which is a complex number. So we discuss about imaginary numbers because it's part of the complex numbers. What is a complex number? So here's how number system works. First, when number were first invented, we had natural numbers. Natural numbers are counting numbers, 1, 2, 3, 4, 5. And then finally, we included the number 0. We call that the whole number system. These are number system. And finally, we include the negative number, so we have to expand this number system a little bit bigger, and that's called the integer number. And then finally, we included fractions and decimal, and then we expand this a little bit more. We call this the real number system. And finally, we expand this one last time to a complex number system, and that's really big. Okay, this is called a complex number system. So what's a complex number system? Well, a complex number system contains the complex number system contains complex numbers, and that's every number that you can think of. So every natural number is a complex number, every whole number is a complex number, every integer is a complex number, every real is a complex number, but not the other way around. So complex number contains two parts. So it contains the real part and what we call the imaginary part. So we call this the real part and the imaginary part. Okay. We can apply regular operations to complex number. So we can add complex number, we can subtract, we can multiply, and we can also divide complex numbers. So let's take a look at adding complex numbers. When you do add them, what you do is you kind of put you identify the real and you put them next to each other. So looking at this statement, I'm going to go 3 plus 4 and then plus 6i minus 2i. So 3 plus 4 equals to 7. 6i take away 2i is 4i. So there you go. When you add two complex numbers, you get another complex number. That's the real, that's the imaginary. When you subtract complex number, the first thing you do is you distribute the minus sign. So you go 3 minus 4, and then 6. And then when you distribute that to that, that becomes a plus sign. So you get 2i. 3 take away 4 is -1. 6 plus 2i is going to be 8i. And that's another complex number. So there you go. You just added two complex numbers. I'm sorry, you just subtracted two complex numbers. We're going to go ahead and multiply complex numbers now. And multiplying complex numbers is actually very similar to multiplying two binomials. So what we're going to do is going to take 6 and we're going to distribute to that, and then we're going to repeat the same thing for the number 2i. So 6, 3 minus 5i plus 2i times 3 minus 5i. 6 times 3 is 18. 6 times 5 is 30. 2 times 3 is 6. 2 times 5 is 10, but this one is special because you're going to have an I times I. That becomes an I squared. So then you have 18, and then this becomes, if you subtract, you get 24i. This is negative 1, so this becomes a plus 10 because you have two negative signs. So when you combine the 18 and the 10 together, you can add them together. That becomes 28. And then your 24 is right there, so that becomes, so it turns out that when you multiply two complex numbers, you get another complex numbers. Same thing over here. This one is a little special because this one's what we call differences of squares. You notice that these two complex numbers are the same, they only differ by a plus sign. So therefore, to multiply them, we can use a special formula, if you like, which is the one I'm using. Square the first one and then square the second one, subtract them. When you square this one, you actually get 16i squared. 9 minus 16. I squared is negative 1. That brings it to a plus sign. You plus 16, that becomes 25. Okay. Dividing complex numbers. When you divide complex numbers, you have to get rid of any I in the denominator. I cannot be in the denominator. So the idea here is that when you have complex number in the denominator, you must get rid of it, and the way how we get rid of it is we use the conjugate. Now what's the conjugate? Well, the conjugate of 2 plus 3i is the same as itself, but the only thing that's different is you change this operation from a plus to a minus. So that's the conjugate. So once you have written down the conjugate, if you multiply the bottom and the top by the conjugate, which is the same as the bottom, only differ by a minus sign, then it turns out that the bottom will no longer contain an I. Okay, so let's do it and see what we get. I'm going to use the shortcut just like how I did here. So then you have 2 squared minus 3i squared. That becomes 4 minus 9 times negative 1 because I squared is negative 1. So therefore this becomes 13 because you're going to be adding these together. In the numerator you do have to FOIL, so you go 5 times 2, that's 10. 5 times that's negative 15. This times this, that gives you negative 2i. This times that gives you positive 3i squared. So what do you have here? You got 10, and then that becomes minus 17i, and then this becomes negative 3. Okay, why does that become negative 3? So 10 minus 3, that gives you 7. And therefore, this is what you have. But then you must split them up because that's not how we write a complex number. So we write it like this. Okay, so you can divide two complex numbers and you will get another complex number.